Calculation of approximate number of solar panels in the solar home system. In this session, we're going to be talk about how we can calculate the number of solar panels required actually in a system to satisfy the needs of the consumer over here. Basically, as per the wattage requirement and watt hour requirement of the consumer, basically, according to that, we're going to change the number of solar panels required to fulfill the needs of the consumer. But before that, we're going to be see actually before we proceed for any case study. So in this case, we're going to see actually how we just do the connections for the solar panel and how we can calculate the overall number of approximate number of solar panel that to be required to be connected in the series or parallel combination in the given circuit. So we know actually the solar cell is made up of the polycrystalline type of a structure or the monocrystalline type of the structure. So the number of solar cells we are connecting row wise actually over here, and like in the series combination we are attaching the solar cells over here actually. And that is why whenever we just join the solar cell in the series combination by joining the bus bar intersections with each other over here actually, we are getting some amount of the voltage over here regarding let's say 30 volt, 37 volt, and the current approximately we are getting greater than the 8 ampere over here. This voltage and the current what we are getting, it depends upon the what quality of a solar cell we are using, how many numbers of the bus bars in the corresponding solar cell it will have, and the total number of a quantity connected in the series combination. So according to that, this voltage and the current is getting changed over here actually. So most of the cases, utility scale type of the solar panel will start with the wattage capacity from 250 watt peak up to 550 watt peak over here. So in this case, we are going to use the 72 number of the solar cells and the 12 numbers of the cell in each row, and such as 6 rows are possible over here actually. So actually whenever we join the solar module in series combination, so it will become one string of the solar modules actually. So in the solar home systems for a smaller capacity we are designing, so that time we can just decide actually how we can connect the panel in the series or parallel combination as per the charge controller rating, as per the overall battery system voltage what we are considering. So that parameter will going to be talk in subsequent case studies in this course over here. But before that, whenever we join the solar panel in the series combination, series in a sense the positive and negative, if we say this corresponding solar panel, positive and negative terminal. So negative terminal we are connecting to the positive. So simultaneously also we are just connecting the negative to the positive over here. So like that, basically what connections we are doing, it is called as a series combination over here. Series combination we are using just to increase the voltage, but the current will remain same over here. So like that, if the number of solar panels we are connecting in some series and some will have in parallel combination, it will called as a solar array over here. So overall solar system, solar panel, what we are deciding, it is called as a solar array. So one by one, we're going to see actually how we connect the solar panel in the series combination and how it going to affect on the voltage and the current requirement for the individual circuit. So basically, let's say we're going to take the solar panel or solar module will have a rated voltage of the 12 volt and the current will have the 5 ampere. This is the rating of this corresponding solar panel what we have selected. So if the two solar panels we are connecting in the series combination, it means what? The negative of the first panel we are connecting to the positive over here with the help of the wire, with the help of the MC4 connectors over here. So like that, whenever we join the panels in the series combination, so our voltage is getting increase over here actually. So let's say the 12 volt is the individual voltage of a panel and multiplied by the two panels we are connecting in the series combination. So we are getting the voltage of 24 volt over here. But the current will remain same over here actually. So whatever the individual panel will have a current, the same will going to propagate in the strings over here actually. So in that case, the current will remain same. Though we connect the 4 panel, 6 panel, 12 panel, 24 panel, current will remain same over here. This is the electrical law we are following whenever we decide the number of panels or we connect the number of panels in the series or parallel combination. Now in the second example, so total 1, 2, 3, 4, 5, 6, 7 and 8. 8 number of solar modules we are connecting in series combination. So negative of positive, negative to the positive like that with the help of MC4 connectors. we are connecting the solar modules over here actually. So individual module will have the voltage of 12 volt multiplied by 8. We are getting the 96 volt is the string voltage also we can say. So if the 8 modules we are connecting in series combination, so whatever the voltage we are getting at the terminals of this string actually, it is the 96 volt. And such kind of a combination we can call it as a string combination over here. Current for this string is will remain same, that is the 5 ampere, because it is connected in the series combination purpose. Now in the second example, we're going to be talk about over here what will happen when we connect the panels in the parallel wiring or in the parallel combination. Parallel combination simply means that if we are taking the 2 or 3 numbers of the solar panel, the positive of each panel we are combining by one wire, and negative of the each wire we are combining by the another wire. So simply we are just collecting the terminals of the each and every solar panel. So same terminal we are connecting with the help of the pre-assembled PV wire, and neutral terminal we are just joining with the help of the pre-assembled PV wire. So that is the main difference between the series and parallel wiring connection whenever we are joining the solar panels in the solar home systems. Let's say for example, we're going to take the solar panel of the 12 volt rated voltage and the amperage range of the 5 ampere, that is the individual solar panel we are taking. And the 3 solar panels we are connecting in the parallel mode. So in this case, the positive of the 3 panels we are combining by a one wire, which is also called as a pre-assembled wires over here. So further this connection we can give to the charge controller or the inverter over here. So this is the positive wire we are taking, and simultaneously the neutral connection also we are combining by the PV pre-assembled wire, and this we can give to the controller or the inverter over here, whatever our system will design in the further process. So in this case actually, whenever the panels are connected in the parallel combination, their voltage will remain same over here. It might be the 3 panel, 4 panel, 6 panel connected in the series of parallel combination, but the voltage will remain same over here, that is a 12 volt. But the current will remain increase over here. So let's say the individual panel will have a current of the 5 ampere multiplied by the 3. We are getting the answer of 15 ampere is the individual string combination over here actually. So in this case, the 3 panels has been connected. So the terminal point of view, we are getting the 12 volt, and the current we are getting is the 15 ampere over here. So in the parallel wiring, the current will increase, but voltage will remain same over here. That is the main motive of this learning of the parallel wiring combination. Now, whenever we talk regarding the series and parallel combination, this series and parallel combination required whenever we matching the system voltage for the controller, or whenever we want to give the connection through the strings or to the particular inverter. So that time we have to do some kind of the connection over here actually. So let's say we're going to take the 6 numbers of the solar panel in the corresponding combination, out of which the every 2 panels we are connecting in the series combination. So let's say the panel number 1 and panel number 2 are connected in the series combination. So negative is connected to the positive over here. Simultaneously, the panel number 3 and panel number 4 are connecting in the series combination, negative and the positive. Simultaneously, the panel number 5 and the 6 has been connected in the series combination over here like this. So individual module will have the voltage of the 12 volt and the current of the 5 ampere over here. So these 2 panels we are connecting in the series combination. So it is called as a S1, which is a string number 1. This is your string number 2, this is your string number 3, because we are connecting in the series combination. So every string output, when we calculate it, we are getting as 24 volt, because in series the voltage has been increased and the current will remain same, which is a 5 ampere over here. Simultaneously, the output of the string number 2 will be also 24 volt and the current will be the 5 ampere. Similarly, for the third string, 24 volt and the current will be the 5 ampere. Now, these 3 strings now will going to connect in the parallel combination. So this string number 1, which is your S1, positive we are combining with the help of the pre-assembled PV wire, and neutral we are combining with the help of the pre-assembled PV wire. Similarly, string number 2, positive we are just combining and negative we are giving. Simultaneously, the string number 3, So all the three strings we are taking the positive wire and combined neutral wire over here. So in this case, string number 1 will have a current of the 5 ampere. String number 2 will have the current of the 5 ampere, and string number 3 is also having the current of the 5 ampere. But whenever the three strings are connected in the parallel mode, the current will getting added over here, but the voltage will remain same. Then the voltage will remain same as an 24 volt, and the current is 5 ampere multiplied by the three strings. So we are getting the current of the 15 ampere. So whenever with the help of the clamp meter or the particular ammeter over here, when we just measure this terminal voltage and the current of this corresponding combination, we are getting the voltage of 24 volt and the current of the 15 ampere for this combination over here. So later this voltage and the current will going to give to the controller or the inverter as per the design, and then we can do the further designing in the solar panels over here. Now we're going to see how we can calculate the number of solar panel that to be connected in the system actually. So let's say for example, calculate the number of panels required for 500 watt solar home system, which is a smaller capacity of solar home system. Consider the solar panel rating of each solar panel will have a rating of 100 wattage over here. So if I want to calculate how many number of solar panel to be required to be connected in series or parallel mode as per the requirement, so we can just do the connections over here. So number of solar panels is equal to size of the solar home system in watt, which is the 500 watt is our requirement, divided by rating of the individual solar panel. So in this case, the individual solar panel will have a rating of the 100 wattage over here actually. So from this we can calculate total 5 number of solar panels are required to fulfill the need of the consumer for the 500 watt solar home systems. So simply what size we required divided by the rating of individual panel what we are selecting from the market, so that we have to take it in the consideration. According to that, we're going to be see in the case study how we just matching the voltage and the current at the individual string basis and the individual connection basis over here.